All right. I think I'm going to get started here as people still are joining. I'm Lavanya Ramakrishnan here at Berkeley Lab. I am the division deputy for the scientific data division. My research background is in more workflows and data management. And today I'm going to tell you how we came to embrace user experience in our scientific ecosystem and how that has led to this new project and some products that we've been developing in called Strudel. Before I get started, the superstars are the team behind this that have been working really hard for many years, in some sense, trying to build the foundation for what we've done here, but also some of the products that we are developing and also provided a lot of help in getting these slides together. Before I get started, I'd like to talk a little bit about, what we do here at Berkeley Lab. We are a national lab that focuses on many different sciences. And what's at the core of what we do is really team science. We really bring together interdisciplinary teams looking at various aspects of science and looking at trying to solve sort of the big national problems that are faced in our society today. The picture here on the left shows the big team science in 1931. We were the first national lab to be established. And on the right, you can see our site with a magnificent view of the bay. And we also have a number of Nobel laureates and groundbreaking research that happens here. So to just give some context to how we came to user experience research, I want to start with sort of what my team here does at Berkeley Lab. And really what we are trying to do is to say, how do we enable researchers to effectively and efficiently manage their computation and data? Here at Berkeley Lab, we have a number of user facilities and also large projects that have a large amount of data that is being produced and hence data processing and also simulations and things like that. So a lot of what my team does is sort of looking at workflow management, building data abstractions, managing those computations and data on HPC and distributed systems, resource management, more recently looking at autonomous pipelines, and making sure that whatever we do is reproducible. On the data management side, again, we do a number of things from understanding data change to search, to just managing these data pipelines that are advancing science and society. So what this talk today is about is to sort of say, why does user experience matter for scientific software? And how our team here views UX for scientific software development, and how our experiences, I would say, about the last decade or so has led to Strudel as a way to provide open source tools that help teams build more usable scientific software. So how did I get here? I'm a computer scientist by training. Back in 2001, when I was in grad school, I took a class on design and UX. And, it was, like many introductory UX courses, we sort of talked about design and the difficulty of designing good products that are also usable. And I learned a lot trying to understand sort of the lay of the land. But it was a graduate requirement class. I left it behind, went on to do a job. In 2005, when I used to work for RENC, the Renaissance Computing Institute in North Carolina, we were building this North Carolina bioportal. And one of the sort of things that struck out to me during this process was after we built the tool and we were doing these workshops, and training, I sat in the room and I realized that we had built a tool that showed people 140 bioinformatics applications that they could take their data and run those applications. And I'm sitting there in this training workshop, and realizing that what people were doing is actually a sequence of these applications. And we not built tooling to support that. And really what they were doing was copy pasting this into an external notepad. And I looked at them and I said, hey, we had so many conversations. why didn't you tell me that, you needed to really copy paste what you were doing, copy paste data into these forms and then take it out into an external application to hold it and then click on a browser again, because I could have built you tools in the browser to make this all happen. And what came from those conversations, which, it took me many years to realize that that was what was happening, was, we had never inquired about how they were using these tools. We only heard that they needed these tools. But I also sort of understood much later that understanding how people use the tools is not enough, but also understanding the implications and the social culture around how these tools are necessary and important and how they're used in the larger context is going to be very important to build usable software tools. So forward to 2012, I'm here at Berkeley Lab. We have a retreat. We're talking to domain scientists from various places. And we're sort of asking them the question of, what do you want us computer scientists to do in the next 10 years to help you out? And every single one of them came and said, we want you to build us workflow tools. And Dan and I were in the audience in the strategic retreat, and we just snickered, right? Because we were like, oh, everybody's built workflow tools, and we don't need to do this, right? But 12 years later, people are still asking for workflow tools. And so this really led us to go back and sort of say, hey, what are we missing as a community here? Let's think about it. And that's exactly where our user experience journey started, because we sort of realized that not only did we need better usable tools for users to use, but that as a practice, we were missing on how these tools were built, and we needed to have a process and understand this better. So we had Sarah Poon here, who used to do a little bit of design at that point. So we sat down with her, and over time, we've developed sort of these UX practices and grown the team here, as you see today, to sort of look at the whole UX pipeline from research, understanding the users, design, which is how do you design good products, sort of evaluation, testing, and making sure that we implement good products. So I'm going to pause here for a minute, and we're going to do a Menti poll. I have a little dance to do here because I have to switch tabs. Let me see. All right. So you can open up the Menti poll using this QR code, or go to menti.com and enter the code that is listed on this website, on this slide here. And I get some thumbs up. That's great. People seem to be on it. And I am going to move to the next one, which is our first question, which is, in 3 or less words, what's your role in a scientific software process or team? All right, I'm waiting for responses. One response: user experience designer, UX strategy, user researcher, design outreach, communication coordinator. We have quite a diverse crowd here: research scientist, product owner. All right, I'm going to wait for a couple more minutes. I see, or maybe a few seconds. Design and UX are lead. I'm happy to see we have a lot of UX designers. We have some PIs and software project managers and scientists and product owners. All right, moving on here to the next question. What does user experience mean to you? I told you my experience is starting out. Give me a few words on what user experience means to you. User first, I like that. improving the accessibility and reproducibility of research code and data through user interfaces, satisfying experience doing the job that needs to be done, focusing on usability, skating to the puck, understanding a user and building an interface that matches their needs, focusing on how users will solve problems with your tool, how the users think about your product and use it to their benefit. That's what I work for. Good experience creates a nicer world in general. Yep. Thinking actively about the design of a tool to make something that fits user needs. All right, thank you. Thank you for participating in this poll. I, just wanted to get a pulse and sort of move on at this stage to tell you a little bit more of our experiences. And I, of course, have a little trouble here, going back to my slides. Okay, so why is building usable scientific software so challenging? I've been doing this for a couple of decades now, and there's always challenges when we're building it. And I know many of you here in the audience have probably experienced it if you're here today. I come from it from a little bit of a workflow lens, and part of this is the realities of scientific work that we don't account for. They don't fit into nice graphs. They are often chaotic. This is a screenshot from one of our collaborators of just how he has the software and scripts and data and all of that sort of organized really in his head, and there are connections that exist between them that don't fit nicely into graphs, and there's no easy way to capture that, right? The second thing is often there is context and artifacts that are not captured, right? We have the digital world, but we still have lab notebooks. We still have other user tools that don't maybe fit into the primary ecosystem that we are developing here. And how do we sort of bring those realities into an ecosystem is still sort of a very hard thing to do. This last but not the least is collaboration stacks have very complex artifacts, right? So you often bring pieces of software from different people to make it all work, and those are very tough. One of the other things, what I talk about is in these collaborations, when you're talking to different people, you sometimes don't know everything that's happening. The picture I have here from the Ameriflex project is an example of how someone out in the field is capturing capturing data is submerged hip deep, right? When any of our conversations early on didn't reveal this, but it was when we had a field site that we sort of realized what the conditions were, right? So in these conditions, trying to collect data where there's limited mobility, limited mobile signals or anything else. You need to account for the fact that they don't have necessarily free hands. So it has to be really easy to use. These were factors that we would not have considered in developing the UI if we didn't actually see what the users were doing, right? So that was important. But the most important thing that I like to highlight is it's most new work practices and tools even that don't fit into current work processes will likely not get adopted, right? It takes, we all have read enough out there literature about changing habits and things like that. And, most of us have a lot of things going on. So we need something that fits into our workflow, right? So if you are asking a user to do something substantially different from what they were doing today, this isn't going to, they're not going to adopt it, right? So that's something we have to keep in mind here. So how do we see UX in scientific software development, right? So scientific software projects involve as much art as much as science, right? There's a lot of things, there's a lot of context, there's a lot of things in scientists' brains that they are sort of processing and trying to make guesses and things like that that don't get captured by digital artifacts. What I like to talk about here is a lot of UX is like working in the kitchen, right? Pastry making is a good example. As you can tell, our team here likes food, and so especially pastries. So, when we sort of make pastries, yes, you start with a recipe, you're sort of making it up a little bit as you go, But think about what else you're doing, right? Because when it's, we are mixing the dough, or, you're making the filling, you're doing certain things, but you're also parallelizing your work in some way. And then when it's in the oven, you're probably sort of preparing for the next thing, doing the dishes, things like that. And those things don't get counted for when you're thinking about pastry making, right? But that's part of the cook's workflow or your workflow in the kitchen, and we need to think about that. So what Strudel is, a quick takeaway here before, we'll come back to it in more depth later, is it's really enables teams to create user-centered software for scientific communities. We plan, design, and build better scientific software projects if we are able to use the Strudel planning framework and design system. And we are really wanting to make sure that the community has access to these projects that we are developing and beginning to use in our projects. So what is UX? Really, UX or user research is a process to verify and validate your intuition about what the user needs, right? It's a hypothesis that you can convert into an action in some sense. And a lot of my UX team here really sits between the research and development team that may be either developing software products or even just doing research, and the users that have the requirements of the science needs. So much of what we've developed here has been in this context of building these teams, interdisciplinary teams, building that team science that involves the social context and an understanding of the users. So I'm not going to go into a lot of depth, but if you need to sell UX up, I like to show this slide where UX research processes can significantly improve the research and software outcomes, right? There's research that shows that it increases productivity for the end users, it decreases the development costs and time, there's increased adoption, better and or lesser documentation and training that's required if you do UX in your processes, and you have fewer errors and bugs and lower costs in a longer time scale when you look at it. When we do UX, I like to roughly say what we do is discovery and explorations. A lot of this is interviews, contextual inquiry, observations, some amount of competitive analysis, trying to understand the space and trying to understand the user needs. From there, we often go into synthesis. Synthesis can be in the form of design constraints or considerations, scenarios, journey maps. Some of these terms are, familiar to software developers, but some of these come from the UX land, and bringing these additional tools really help us improve the outcome. The next stage is usually design. You'll have some wireframes or a prototype or a detailed mock-up that you can then test with the users through usability tests. Of course, it's never this linear and never this clean, as our team often comes in where there may already be a prototype, there may be a product that hasn't had the uptake they were hoping for, or they have some usability challenges. So we don't always get to go in and start out with discovery and exploration, right? So we may come in at any stage in this sort of higher level pipeline, and then help the team sort of iterate and pivot or iterate and evolve as whatever our studies show. So how do we define user experience? We've evolved from sort of saying it's art and science to saying it is the practice of developing services and products that provide consistent, relevant, productive, and joyful experience for users. A lot of this is common in industry. We hear, the Googles and the Amazons having UX teams. This is much newer in our scientific environment. And one of the things I often get is, oh yeah, but UX is really focused on graphical user interfaces or a web interface, and we can just do that at the end, right? And that's not it. UX is really a practice that helps to sort of shape the internal organizational processes in the software development to impact the user interfaces of all kinds, right? These can be APIs, but it also improves sort of the interactions among the systems and the users, and actually even teams, right, between the teams. We've done a number of exercises where we've sort of being able to bring teams together just using UX practices and converge on some basic ideas. So one of the early works in our sort of what we did was sort of put out a paper on what were our 10 principles for creating usable scientific software systems, right? This is from a long time ago, but I like to still show it, which, it's important to solve the right problem first. It's important to understand the context of use, but it's also very important to understand the user's metrics. And often, that's not performance. That is a metric that we as computer scientists and facility operators and things like that like to use, but the users are often thinking about other metrics, whether it's scientific productivity or their own time. All right. So why, we've talked a little bit about why UX is hard, why the workflows are hard. But I want to talk a little bit about the structure of teams, right? Which I think plays a very important part in how we build scientific software. Planning, design, and stewardship of the scientific software is often chaotic, right? Because we often don't have fixed roles. I wear multiple roles on, and in every project of mine, I may have a slightly different role on what I do. So often software that's being developed is being developed by people who have other jobs, right? And that is important to recognize and important to understand. Management and planning is often ad hoc. We don't usually have significant management structures in a lot of scientific projects. So we are also responding to emerging scientific demands and needs, right? A good example would be the pandemic from recent years, where some of the teams needed to pivot and just try to come up with solutions that they were studying to address the societal need we had at that point, right? But what's more also important to understand is we are resource constrained, right? We don't have time, we don't have dollars, we don't have people. And it's important to understand that, that plays a crucial factor in how we design software and how we build teams. And making small tweaks is important, and figuring out how we can have UX not be an afterthought in this process is important, right? It's, I talked a little bit about industry on and off, but I think it's important to understand that we do not have a product management role in our community, right? Who stewards and user vision and user engagement and things like that. So I think these are realities of not just the workflows, but also the people and the environment and the context that we need to consider when we are thinking about planning and developing software. So, as a quick sort of aside, we've come to Strudel from building on our experiences with incorporating UX in many scientific projects, right? A lot of early work we started out was as consultants, typically design or some usability research for various large projects, sort of looking at what they were doing and how we can improve those, right? Over time, we started incorporating UX as a key part of our R&D projects, looking at sort of future problems and trying to understand some of the social implications of tools and research we were doing on the computer science side. And this has systematically been expanding sort of our abstract insights and sort of taking that and putting into Strudel is what we've been doing for about the last year and a half or so. So before I jump here into the Strudel vision, I'm just going to pause and just check if there's any questions anyone has. You are welcome to raise your hand or unmute and speak up or put it in the chat. You're also welcome to keep putting questions in the chat, and I can come to them later if you don't have one at this point. All right. Oh, Michael.
Yeah, hi, thank you. I have a question. In your experience with the UX activities, how have your sponsors responded or supported or maybe initially even skeptical of this activity relative to other things. Does that make sense to what I'm asking?
I think that's a good question, Michael. I think, one of the things to keep in mind is, as always, like everything else, we get a range of different reactions, right? And I would say it's been mostly positive because people have seen some of what we've been able to do. I'd say from the more applied side where people see it on their products, it's been overwhelmingly positive because when we go in and we are able to fix some issues, they can see the immediate results. In terms of sponsorship, we have, there are some people who just sort of say, oh, that's the thing that Lavanya does, and mostly they ignore it. And then we have others who know that this is a secret sauce, and that they understand that this is important for the community. I would say, we've had Sloan Foundation reach out to us, so they definitely believed in us, and believed in these methods, right? And that was very important for being able to build this community and also being built the longer term vision. But I've also seen an uptake, in the last, I've been doing this for about 12 years or so, where I hear user experience and UX now in more meetings than I go to, right? A lot of what has happened in the IRI space and DOE, Oscar, has more sort of grounding in the UX experience. And so I see that as a positive.
Thank you very much. And I like this work. Don't get me wrong. I'm not skeptical.
I know that. Thanks for being our supporter. So. All right, so what's the long-term Strudel vision? We have a little cartoon here. If you didn't already start reading it, I'm going to quickly walk through it. Usually, you are in a science laboratory, you're starting a new project, often there's chaos, right? How many people do I need to develop this software? Who all do I need? What's the timeline? How much should we invest in UX over timeline? Don't you wish, especially some of the PIs here, don't you wish you had a project planning assistant who would just go in and start to sort of put these numbers, put some thoughts into the project, ask some questions, and just give you the magic recipe? So we're definitely not at that stage where we can give you the magic recipe, but we do eventually visualize that there will be sort of this AI type assistant who could take the data from other projects and be able to sort of give you some ranges and some ideas on how to approach it at the starting, right? So what we've been doing largely in this space is trying to build up sort of this typology to build this planning assistant long term, which I'll talk about later. And what it would do is give you these suggestions that you can then use to plan this project. And then you come to this point where you want to develop the UI for it. And Strudel has a design system that we provide where, given the patterns, it would give you a foundation to start out building the UI from, right? It'll give you some ideas, some design, and some early implementation. So our goal here is really to develop those products that help scientific software teams simplify adoption of both UX approaches, and lead to a better world where we have more usable, sustainable scientific software. So I'm going to spend just a few minutes here on talking about our user experiences, and sort of where we are with some of the things we've learned along the way, just to show you some case studies, right? So many of you who may be familiar with the high performance computing systems will sort of relate to this step diagram that I have here, where you often get some allocation, you get some preparation of you do some preparation of your applications, you submit your job to a queue, then you wait for it to run, and then you have some post-processing that you may do, right? So we're in our very early days of trying to sort of look at this in a more abstract way. One of the things that came about was, a lot of what we focus on is the machine time, right? The optimization, the performance. How can we make the compilers better? How can we make the queue wait times lesser? How can we schedule and run jobs faster? How can we make the data move faster? But really, the end user who's using these tools is looking at productivity, right? So you want to get some code running. How long does it take me to get this code running? How long does it take me to manage this data? What do I do when I'm waiting for those jobs? And how do I debug these results if they don't run when on the first go when they're executing? And then when they're doing sort of the post-processing, sort of how do I do that manual data management? How can I make my life easier, right? And this disconnect often leads to us not realizing that when we provide them tools to optimize and run their jobs faster, they don't adopt it, because this adoption might mean their workflow is broken because they've figured out a system to keep this all running. For example, I wait for my job 8 hours, and that's okay because in those 8 hours, I go and write my paper, right? And so they are not really motivated to make changes. And that we need to sort of bridge across that disconnect, right? And so the metrics that we might look at versus the metrics the user might look like tends to be a very significant factor in this. A more recent study that we did, many of you might be familiar with Jupyter, and Jupyter has been used for a very long time, but it's just much more recently that we've used it on HPC systems, right? So we did a UX research where we talked to the users to understand. And while Jupyter was really easy to use on the desktop, there were a number of challenges when they were trying to work through the Jupyter system on an HPC system, where they either didn't understand the configurations of the environment, or the facility maintenance windows didn't get reflected in the Jupyter system they were there. And how do you sort of customize and share these instances and things like that was tricky, and people wanted more, right? A lot of this actually led to our research and development project that we are finishing up now, which we call SciData, just looking at sort of the issues in the Jupyter ecosystem and trying to optimize that to have a more collaborative, scalable, interactive environment on HPC systems. So what really I want to leave you here with is, we have a simple, way of thinking about software development, even though it's usually not as simple as I talked about the kitchen example earlier. We have development, we have testing, and we have release, right? User research methods can weave closely with this R&D process to produce better results, right? So it's easy to conduct sort of semi-structured interviews or have some mock-ups, do some quick things to improve your process with minimal sort of changes to your ecosystem, but with a large impact. All right, time for another poll here. So if you don't mind going back to your browser, and I'm going to try to do the same here. All right. Okay, so tell me a little bit about what are your challenges in planning, designing, and developing scientific software? What did I miss, or what resonated for you in what I said? That's a common problem that we often want to just implement because we like to have some tangible outputs. So it's always easy to jump in. Others, do you have something else for me? Adjusting to project timelines, adjusting to shifting timelines. This is a constant problem. Conflicting team priorities. Yes. Having collaborators understand how long it takes to do user research. Moving quickly and responsively to user needs. Demands for doing novel research and no direct funding for producing good software. Yes. Yep, more ideas as we go. Correct, notebooks are useful. Technical debt is definitely something we have to keep in mind. I like to say that UX reduces the technical debt. And sometimes you do have to stop and refactor. All right, so I'm going to move on here. What are your challenges in developing a user interfaces, web and API for scientific software? I'm beginning to wonder if no one has any challenges or if I just got disconnected here. All right, understand the skill sets needed to develop a tool. Users collaborate, user callable libraries are not the typical product for UX. All right, complex user needs workflows. Too many opinions from different perspectives. Some stakeholders wait well past design stage to provide feedback, so much more expensive to fix. It is for sure. Finding qualified people willing to do the work, yes. Different behaviors throughout the semester means long data collection time for UX, yeah. All right, can I get one more? And there you go, building UI pipeline in parallel with research before output data may exist. That is, I think, a natural, big problem, especially with scientific pipelines, for sure. All right, I am going to switch here on the interest of time, and go to back to my slide. All right, so we have a couple more events planned for more detailed discussion on Strudel, which is a much more deeper dive into the system itself. But I do want to leave you here with a little quick introduction, so you know what is coming. So in terms of what Strudel is, it's really bringing these tools together to improve the scientific software design life cycle, right? So how do we do some pre-requirements? How do you plan your project? How do you design your software? How do you build your software? And how do you test and evaluate this software? You know, as I think I've highlighted multiple times, this is not a clean, linear process. It's iterative, it's more squiggly, and not necessarily these clean, nice lines and boxes. What I do believe also that the software design life cycle sort of is interdependent on various things that are happening in the project, right? And I really would like to start seeing scientific collaborations be centered around three things, right? The community engagement piece, which is sort of where you reach out to the community, understand the requirements. You also sort of use that to engage with the community when you have products and things like that, right? But there's also key user research, which I hope we will do more of in our community, starting to really sort of use methods and processes that are structured and looking at the experts to really tell us what the users need and engage with the users and things like that. But a key part of this that I feel like they all tie together is software sustainability, right? And if we build broader products that are more usable, we will reach better software sustainability. But there's various different aspects to software sustainability, and we need more key investments sort of in all of these parts of scientific collaborations, right? Community engagement, user research, and software sustainability. So what we're trying to do with Strudel is really sort of trying to provide that foundation to build that kind of ecosystem, right? So I talked briefly about our planning framework. That's still a work in progress. The typology that we're developing will inform this planning framework. And then we have a design system with task flows. So what is that, right? I'm going to tell you more about this. What I have at the bottom of the slide is, a simplified version of this life cycle that I showed in the previous diagram, and I have cues on every slide about which product helps you which part of this pipeline, right? And this is not exclusive. We need more tooling, but we hope this is a starting of a conversation in the community. So when you look at sort of the planning part of a project, there are many different dimensions that affect how you plan a project, right? Which is, what's the project composition? What's the science domain? What's the primary purpose? What's the funding model that you're getting to build this? If you have 3 years, it's different from if you have 5 years. If you have 10 years, it's different if you have a longer leeway of how you're building this up, right? The people and teams matter too. You could have a small project, you could have a large project, you could have roles and compositions which affect how you structure your projects. You may have domain scientists, you have software engineers, you may not have software engineers, and it turns out the physicist is writing the software, right? The diversity of experience matters too, and something that you need to consider. The software products are important in terms of what are the required types of apps, what are the data types, what is the size of the user base you're targeting, do you know your user base, what is the computing paradigm that you may be looking at, right? So these factors, if we were able to look across these factors on 10,000 projects, then we would be able to start answering the question of what's the best way to structure the project and what have we learned from it, right? Getting that kind of data is really hard, but we're trying to build this typology, which will eventually lead us to a more strategic planning framework, which if you were able to pick some high-level answers to the questions in these primary facets of typology, then you'd get some recommendations on how to think about your project and how do you plan your project. So this is, I'd say, we have some early sort of things we're doing in this space. We have some thoughts, and we're going to put out some paper and things like that. If you're interested in engaging with this, with us in developing this framework or using this long-term, please reach out to us. We would love to have community input into this early, right? The second part of our work is really a design system, which is really a set of reusable components and patterns for designing and building UIs, as well as guidelines on when and how to use them, right? So what is unique about the STRUDEL design system? There's a lot of design systems out there. This is really specifically built for scientific UIs, right? It thinks about the common patterns across scientific domains. It focuses on sort of the larger flow and function of UI, and allows you to get a jump start to think about that entire UI flow rather than starting from scratch, right? I like to say that it's designed by experts for experts, potentially different type of experts in both cases, but it's really informed by over a decade of our collective UX experience in the sciences. And we really would like to ask the communities to join forces with us and help us develop these further so we can democratize the good UX practices in the community. So how did we come about this, right? Our designers were helping many different projects, sort of developing their UIs for different things. And we realized we were doing very similar things across different projects, right? There's scenario selection, there's selecting inputs, dashboard or summary of results, and there was history. And part of this, as we started to think about it, we said, oh, there's a very distinct task flow that occurs on these UI products. And wouldn't it be nice if we had some base you could start out from so that not every person was investing trying to design this from scratch, right? Something that really gets you started. So that's really what we did. We're trying to build out these task flows, right? So what is a task flow? It's a series of steps represented by some screens, which helps users to accomplish a particular task in scientific software's user interface, right? Similar task flows exist across various types of these scientific software, as I just showed on my previous slide. So right now we have started out with, I'd say, 3 large areas, which is analysis, data, and exploration, right? We have about 9 task flows that we are developing. we believe that there is more that the community can contribute to this. And we want to make it easy for users to use this, but also for the community to make contributions to these task flows, right? So really an open source community outcome is what we desire here. So if you go to our website, it basically provides you resources for each task flow. So you have some design templates and guidelines, which really show you, if you see here at the bottom of the screen, the sequence of the screens, right? So it walks you through how you would walk through a UI and shows you each of these screens. For each of those screens, you have images, but you also have design files, which is Figma is a very popular tool for this, for customizing these designs. And you have guidelines for adapting the task flow to different situations, right? So sort of documenting entirely what our goal is and how we think of it, but also giving you the flexibility to use it. In addition to the design, we also have the STRUDEL, what we call the STRUDEL kit, which is web interactive templates and coded UI libraries that have been built using React JavaScript framework, using sort of material UI components library, right? So we really have a starting point where literally you will have the code to get you started on building a UI, right? So you could consider different situations where you could use some part of the sequence. You might mix and match a little bit because your workflow is a little bit different, but you have the building blocks, you have the Lego blocks to get you started. So how would you use a Strudel design system example, right? Like I just want to walk through this to just tell you how easy it is. So let's take the run computation one, right? So you select that because you think that's the closest to what you're trying to do. The next level, you then see what the screens are that are associated with it, and you get to see sort of the details to verify that this matches with your expectation. At the next step, you really can sort of go in and understand each of these tasks, each of the screens and the task flow, and map it to your requirements and plan the customizations, right? So we would recommend sort of, you could do, pull this down, print it out, mark out what you might change in the UI. Really simple to do. And everybody can sort of pick this up from where they are, right? I don't like it this way. I want this vertical. I want this horizontal. You can do, visual, but you can also do content changes, right? I want other data to be shown, things like that. You can plan that out. And this next part of this would be you browse the prototype and code implementation guide from the Strudel Kit UI library, and you're able to sort of walk through and make those changes that you marked up in an earlier stage, right? So you're able to sort of incorporate this into your planning and design early, and get something up and running really quickly. A goal for our team is, we're going to have some hackathons, but eventually I want us to get to a point where really bringing up an UI for a new scientific application, just a base one, not like a full functionality one. I'm hoping we can get it down to less than half a day, right? It should not be months, it should not be weeks, less than half a day. That's our eventual goal, getting to that. So here's, thanks for hanging out with me here today. I do really appreciate that. There are many ways for you to get involved and join the Strudel community. We will have a much more detailed, deeper dive on the Strudel design system that my team will present on March 8th. I'm telling you, this is going to be a lot of fun, so I hope you will join us. We also are planning an in-person at Berkeley Lab design system hackathon. So if you have a problem or if you just want to try our toolkit, come hang out with us, and we will be happy to teach you, help you out as you work through your problem. Our website has a lot more information, and you can use our products from there. If you have comments, you can start a conversation on GitHub. And if the other thing I want to make a plug for is joining the US RSC User Experience Working Group. If you're not already there, Drew Prane and Hannah Cohen are co-chairs of this working group, and they're really trying to build a community around UX. So come hang out with us there. I believe they have a meeting this afternoon. Drew, I'm hoping you'll put a link in chat for that. And please join our mailing list to keep up to date and contribute to the community. So thank you again, and I will take any questions that may be in the chat and or have anybody who wants to unmute and speak up. All right, we can definitely share the responses in the Menti later. We'll send out the slides and all of that information. Any other questions for me? All right, thanks again for coming out and listening to me. If you have any questions, if you have any comments, please feel free to drop me or anyone in the team an email or start a conversation in GitHub. Thanks, everyone.